All right, I think we have a quorum, so I'll go ahead and introduce our next speaker. It's my pleasure to introduce David Grope, who will be talking about trust coordination for research collaboration in the era of European Open Science Cloud. David Grope is a researcher at NSF, the Dutch National Institute for Subatomic Physics, working on infrastructures for collaboration and interoperable policy. He leads the policy development area of the AGIS Authentication and Authorization for Research Collaboration Community, and is a member of the Dutch e-infrastructure executive and involved with European e-infrastructures for the past 2 decades. With that, I'll pass the mic over to David.
Okay, thank you, Scott, and thanks to everyone for attending here and interrupting your lunch probably if you're local, or your dinner if you're over in Europe, and for joining the EOSC. And now you might wonder, why talk about the EOSC, the European Open Science Cloud. I'm David Grope from NSF, as Scott already said, and with a couple of trusted colleagues, it's about trust and security anyway, we thought about how can we structure this security for EOSC. But the first question you probably want to answer is, what is that EOSC? So it's the European Open Science Cloud. And why talk about a European Open Science Cloud to you? Because actually it's not quite European. They try to engage global research and participate and collaborate. It's for both open data, but also for data that's not yet open, but will be fair and open data in the future. It's about all areas of research in Europe, trying to structure the European research area. And it's far beyond what we would traditionally call cloud. It's more a commons, a place where data, services, users can be brought together from all disciplines across all European and global countries. So it's not quite European, not quite open, not quite only science, and not quite a cloud. But it's a collaboration. It's working together, trying to shape, in this case, mostly top down, what data-driven research will be in Europe in the 2020s. And it's gonna be really, really complex, especially if you look at all the security aspects. And to give you a flavor, I just list all the parties that participate in the EOSC. It's the large-scale infrastructures. You may know some of them. CERN in Geneva, the European Southern Observatory in Chile, extreme laser facilities, all kinds of big infrastructures in Europe, brought together with cyber infrastructures. Think of the European equivalents of XSEED or Open Science Grid. They're called EGI, EUDAT, Géant, and OpenAir. And the research collaborations and the research communities that have already been brought together in a couple of umbrella organizations. And that's social sciences and humanities, that is life sciences, high energy physics, photon and neutron science, and Earth observation, all kinds of different domains brought together. And what they try to achieve is working together on open data and exploit that multidisciplinary research that would enable new insight based on all that fair and open data. And to do that, you need a service catalog. You need a place where all these infrastructures, all these services, all this data is actually brought together. And that's visualized in what is the first version of essentially the EOSC portal. It looks a bit like a web shop. And frankly, at this moment, it is a web shop, but bringing together all kinds of very interesting combinations. I looked at the data area of the European Open Science Cloud catalog, where you can find services and data. You can find the amnesia service, and I almost forgot what it's about, but it's about anonymizing patient records and kind of losing your personal data that's complex. But it's positioned next to the French tuna Atlas Spatial Data Catalog, about where you can find tuna fish if you actually want some for your sandwich, which I think indeed is for breakfast if you're in Hawaii, and where do you find them on the globe? Probably they'll want to preserve the tuna, by the way. It brings together lots of very different entities, lots of new things. data sets, storage, computing and publications, digital objects, anything that you can throw at research and that can be digitally represented. It's an open ecosystem. When the EOSC Secretariat did a survey amongst researchers and research collaborations in Europe, 70% said that they would want to see no barriers to entry into this research ecosystem, which is completely understandable because the interesting data in Europe is going to be found there. But they would happily disregard, say, required operational maturity, service management quality, etc., etc. Access to the data is paramount. And it will be a diverse ecosystem with e-infrastructures, with managed services coming in, services originating in the various member states, research infrastructures, and the private sector. SMEs will be both consumers and producers of services and data in the European Open Science Cloud. For security, that wouldn't be all that bad, except that the explicit aim is to provide an interdependent ecosystem, composability. Researchers that recently used a Galaxy genomic server might also be interested in using a Jupyter Hub or Jupyter Notebook. And the EOSC portal is going to promote those links based on, AI technology analyzing the behavior of the users in the portal. Most of it will be around essentially data and services. All of the important elements are around there in that ecosystem. And the core is actually very thin. It's AAI, trying to find out who that user is. It's the service catalog itself. You need a core to find all the other services. And there's a bunch of, documentary services like governance, landscaping, policy, certification, and trademarking. But the technical services, the stuff that's really important for security, is the AAI, based around the ARC blueprint architecture. I'm very happy that Matthew already yesterday in the, the collaboration as a service talk explained all about the ARC blueprint. So I don't have to repeat that one here. But the ARC blueprint is kind of the model where all of these research infrastructure, research services will adhere to. We'll be getting IT service management for the core services. And what we also pushed into the core of the EOSC is operational security and trust policy. But there's a challenge there. We'll be getting all those services, all those data sets, all those providers in. We can't put too many barriers to entry. This is the infrastructure that says yes. So we have to approach security in a slightly different way. And we'll be flooded with new services as the EOSC develops. There are dedicated working groups that set the criteria for getting additional services in. And if they meet on interoperability standards, they will most likely be fully welcomed. So, where are we going with this EOSC? And everyone is agile nowadays. So we ended up with a minimum viable EOSC to begin with, the MVE, of which everyone, of course, has great expectations. But what will it actually do? It will cement that core versus exchange mechanism, where the minimum viable EOSC is a very small core and a mechanism to link lots of new services in, enriching that ecosystem with essentially uncontrolled federation of interesting objects, research, services, and data. Even the core itself will be distributed. There's not going to be any single entity running all of the EOSC core services. It will be a mix, and service providers as well as core providers will have to contribute to keep it safe. They'll have to invest resources in this trustworthy ecosystem. Our experience has shown that if you frame it right, that's not actually unachievable. Even if you started off with a very low baseline, gradually increasing that baseline, like we did, for example, with Certify, the Security Incident Response Trust Framework for Federated Identity, show that you can, over time, entice lots and lots of service providers and identity providers to participate in something that's useful to them. And Certify, I think, now has about 25% coverage across all of education, so all of the global inter-working federations. But we're not there yet for the EOSC. And for the EOSC, we start with something very, very simple. And for those of you who have ever been to Greece or have ever visited the hospital, Hippocrates, the godfather of all medical doctors, said, "Do no harm." And that's probably where we'll start, with the security for the European Open Science Cloud. Whereas traditionally in infrastructures, we have pushed from monitoring capabilities, very well established technical procedures, we are moving back to initially a state of managing risk and telling to the service providers, do no harm. And do no harm to the assets and interests of your users, which seems kind of obvious, but also do no harm in other services in the ecosystem. Imagine that you're a cloud orchestration framework and you ask of users, please give your username and password to us. Yes, we'll take care of that. No worries, we're all fine. And we will procure all those cloud resources for you. We'll orchestrate for you. Just give me your username and password. We've seen those services in existing infrastructures, and users happily give their credentials to such a broker. I was in the lucky position to actually then use that broker without any credentials and happily create virtual machines on AWS. I think that was not entirely intended. But what I've done in that case is expose other participants in the ecosystem to a risk that they created. And that's also something we want to prevent in the trustworthy variant of the EOSC ecosystem. And lastly, we want them to be transparent about their information security maturity level and show that in a way that's not too heavy to both their consumers and their suppliers. So there will be some requirements in rules of participation. And for the core, we've reduced that to 5 key action lines. One is actually promoting self-assessed risk. So know what you're doing and make that clear. Meet a minimal baseline, and we'll help you meet that baseline with reference policies. At some point, it will go wrong, so we'll need a communications mechanism for incident response. And for the cases where you're really into deep trouble, an actionable operational security hub that will take care and will have all the expertise to help you recover into a sane state. And since we want the service providers to gradually mature over time as well, a training and skills program is attached to that. So how do we go about all these individual IDs? And the core one is probably risk management. And we've heard many talks about formal risk assessment frameworks and having, what was it, 1,860 controls for FISMA. Throwing those controls at a research service provider, as we heard yesterday, is not going to fly. So what we wanted to do is actually take a simplified framework that's attuned to research, and we propose the Security for Collaboration Amongst Infrastructures, SCI framework, and you can find that on wise-community.org, which promotes a self-assessed maturity model that you can have peer-reviewed by similar infrastructures and service providers. And you end up with a nice spider diagram that you can publish, and that maturity level can then encourage collaboration between the infrastructures. Because we know that risk will play out very differently in different infrastructures. The compute infrastructure is really different from somebody offering tuna geospatial data. Yet many risks are generic. Some need context, some need expertise to address. This is still complex. And up to now, we've had the benefit of a kind of shared understanding in most of our larger infrastructures. If you're running a network of supercomputers, you know what running a supercomputer means. If you're running a high throughput system like EGI, or if you're a research community like WLCG, you can start with a single simple policy set and a single assurance level, because you know where everyone comes from and you don't have to reiterate all the breadcrumbs you lost in getting to that simple policy. But in the EOSC, we'll be moving to very different models. And we have to realize that there are very many different ways you can go from A to B. If your screen resolution is good enough, you can see the roundabout of roundabouts of Hemel-Hempstead, and you can go through this roundabout in several roundabout ways, taking one or more roundabouts going from one end of the roundabout to the other end of the roundabout. That kind of complexity is something that a normal service provider will be able to understand. So instead of providing complexity, we try to harmonize that using a more simple baseline. And we throw in rules of participation, we throw in common globally established frameworks like WISE, like Certify, like the REFAS assurance frameworks, and come out with a baseline. And speeding up a bit, you can see all these slides online if you want. We provide only a basic minimal set in the rules of participation, and then a set of good practice policy implementation guidelines, technical guidance, and the SCI mapping to grow your maturity level as you participate in the EOSC. If you're a completely new community, we'll be providing a policy development kit. So a set of kind of pre-built policies that you only have to put in a few parameters, and you get a community framework out that's readily understandable by all the other participants in the ecosystem. We'll be pushing as the third direction for good incident response. Looking for communications mechanism, making people aware of things like trusted introducer, REN-ISAC, FIRST, Africa CERT, AP CERT, and exercising their capabilities. This is groundwork we need not only to improve the maturity of the service providers, but also to prepare for the case where incidents will happen. Part of it is training, making sure that people know what to do when there's a problem, but having everyone trained in proper incident response in an ecosystem with thousands and thousands of entities is not going to work, especially if the EOSC doesn't want to put in any barriers to participation, which is perfectly understandable. So in the core, we put in an actionable response team, a few individuals, there are not that many people that can actually do this, with forensic expertise, tightly knit communities linked with all their peers in the world. And that's the team that will glue together EOSC participants and the core in case of real trouble. But we cannot do it all alone. We cannot do it based on just the AAI, for example. And this is actually surprising. Services think that if they connect to the AAI, they will never have a security problem again. Oh, am I being DDoSed by a random Gmail user? The AAI should protect me against it. In the end, that's not going to work, especially since in the EOSC, the AAI will not be just a simple blueprint architecture as a proxy and a hub that can control things, but it will be a full federation, likely next to all the national federations we now see in EduGame. So, are we actually overloading the hub? Will the EOSC core be the one place where everyone needs to go, and slowly our core infrastructure, our core capabilities will be drowned by all the incidents happening throughout the EOSC. That we hope not. We are pushing actively to see also the infrastructures and service providers engage. And we have, luckily, some of the large infrastructures in Europe available, just like you have Exceed and Open Science Grid or Internet 2 in the US. And infrastructures there bring us an important advantage. Service providers individually may need to grow a mature security posture. An infrastructure can provide that across many services that do kind of similar things. The services in an infrastructure can benefit from their commonalities. They may use the same software, so vulnerability management becomes easier. They may deploy commercial software or operating systems in similar scenarios. For example, if you're running compute jobs using a Linux kernel, a local privilege escalation by Linux vendors is typically classified as important but not critical. However, if you are running an infrastructure where anyone can run arbitrary jobs on your supercomputer or your high throughput system or cluster, then a local privilege escalation is absolutely critical. It's as bad as having it almost open to the entire world. So in doing risk assessment, you can reevaluate the impact and criticality of common services or common software. And of course, many infrastructures, especially research infrastructures, share a common user base. And what we have seen is that incidents tend to spread across a community because people hop between different sites, but within the same community. So they also in incident response, infrastructures have a definite advantage. And for the EOSC core services that we're putting in place as part of EOSC Future, it's a very scalable way of talking with users and service providers. So, whilst services are generally very broad, the infrastructures provide significant additional value. So we promote things like having an infrastructure CSIRT. EGI has one, I know PRAISE has one, EUDAT has one, a place where service providers work together in solving those incidents. Similarly for vulnerability management. So our initial idea in trying to shape security and trust for the EOSC is to have those two different pillars, a portal and the infrastructure. And the researchers in that infrastructure will likely be based around the existing groupings of similar research. So life sciences in Europe is centered around the EOSC Life, Elixir, biobanking infrastructures. They already, and that's probably an advantage in Europe, are being brought together because of a top-down approach to structuring research. But we do depend on those infrastructures to provide the coherency and proactive vulnerability management and incident response. But are we unique in that? And that's actually a couple of questions we could discuss in the few minutes that we have left. My biggest fear moving towards the European Open Science Cloud ecosystem is that a core team will drown. There will be incidents spreading throughout the infrastructure, and the core team will see them, will have to react in order to protect the ecosystem at large, protect the reputation of the Open Science Cloud. So they will be busied with kind of firefighting all the individual incidents. Or do actually stand a better chance? Will the policy baseline be sufficient to keep the ecosystem secure? Can we make service providers work together in managing and protecting the EOSC brand and reputation? And will that self-assessed peer review model scale to the extent that it's actually seen as kind of good value to invest in the self-assessment so that you can get those additional trust marks? And do the users care? Users, when they select a restaurant, in many of the kind of social platform, go to Google, go to Yelp or whatever. They look for the star rating of a service. Good security, good trust, good reputation and risk management could mean a couple of extra stars in that EOSC portal and EOSC service catalog. Will that actually attract users? So will the cost of doing that be worthwhile for the service providers? Those questions are open to us, and we value suggestions from you either now or over the coming 4, 5 or 10 years as the EOSC will mature to see where we'll go and whether we actually will stand a chance. And with that, I'd like to open the floor to questions after thanking all my collaborators on the paper. EOSC security for the trust and security for the EOSC era. You can see them listed here. And with that, thanks very much. And I already see a couple of questions come up. So type them in the chat or put them in the raise your hand online.
Yes. So let's get through the Q&A ones I see so far. David, how can researchers leverage on the European or the EOSC infrastructure?
So the idea is that the EOSC will be initially open for everyone. And the other premise that's put in is that the EOSC will be free at point of use. So the idea is that research funding agencies, research infrastructure collaborations, or one of the larger EOSC projects, they will pay for their researchers so that at point of use, you will not have to pull out the credit card. Yet the idea is that most of the research in Europe will be structured around those clusters of research infrastructures. And there are actually 51 of them in Europe. And they span indeed all domains from social sciences, humanities to high energy physics and astronomy. So any researcher that's kind of affiliated to a national funding agency, a research project, or one of the research infrastructures will be able to get access. To which infrastructures they get access, or actually whether they can read specific data, of course, depends on the access policies of that particular service. Like, I'll pick an obvious example from the life sciences. Access to non-anonymized patient data will be extremely restricted, and you will have to sign a data transfer agreement where you promise not to divulge the data and protect privacy. If you're looking for Earth observation data or the concentration of greenhouse gases over Europe as measured by the Sentinel satellites, that data will be completely open. You'll still have to find a compute resource to compute on, but the portal will guide you on your way to find those. Presumably, even based on machine learning, it will learn what the researcher wants and point you elsewhere.
Thanks. I apologize earlier for my mic issues. If I sound clearer, or at least I hope I sound clearer now. Let me just, oh, people are saying it's still not very good. Okay, I will work on that.
Yeah, so we're looking at the next one. How do you manage data privacy on the EOSC infrastructures? There are actually, that's probably one of my hobby horses. You have to separate them in two different layers. One is data, personal data that's generated as a result of you using the infrastructure, some kind of access personal data, and the privacy and security of the data that's actually the research data that's inside the services. The first one, data generated as a result of you using the infrastructure, will be relying on mechanisms like the Data Protection Code of Conduct. I know that will be a long-term endeavor, and it needs 1 or 2 more years at least to get that one to an international level. But processing personal data for purposes of incident response or for purposes of granting access is a perfectly legitimate interest. The data inside the infrastructure may need very strict controls and regulations. It may require you to have two-factor authentication. It may require you to sign contracts between the data owner and you, or between the data owner and your institution, maybe even both. But those policies we leave with the service providers and data owners. So the EOSC will mediate those connections. It will provide the AAI federation that will enable users, research communities, and service providers to find each other. There is not going to be a single proxy, a single connection point where all of the services link together. It's a federation, and it will probably be a full mesh federation that joins like the others in EduGain.
Hey, David, I have another question that was posted in the chat. It just says, do you have to worry about GDPR?
Me being in Europe, I think I always have to worry about GDPR, but I think GDPR is also often overrated. Processing personal data for granting you access to services is a legitimate interest, and it can be argued very well that the attribute set you get for research and scholarship, like a unique identifier, your name and your email address and your affiliation, are a minimal usable set to grant access to services. So the combination of the REFED's research and scholarship entity category and the data protection code of conduct should be enough to provide basic connectivity within the EOSC. Incident response is actually explicitly encouraged under GDPR. And if you want to see what falls under that, I think the only one you have to read is Andrew Cormack's blog. He's the JISC legal advisor, and I've never found him wrong.